Hello students, now we are going to take a quick review on the one and only topic of projectile motion. This projectile motion comes under the topic of motion in a plane. This is the last part of the motion in a plane. So if you look at a projectile motion, the projectile motion can be of, these are three varieties we see. One is from a height, when there is a ball, you just give a horizontal velocity. It just comes, lands up because of the gravity. It is already there on a height here. So you can take a point here and then take a velocity and all these things. The next second part is from the bottom you take a body and then you give a projection. So the body just goes here on a path of a projectile and comes here. So we take this as a velocity and we take two components. It's a theta value. This is v cos theta and this is v sin theta. And the next one is, what is the third part of it? Third part of it is combination of these two. So there is a height and you give a height and then the body comes and falls here. So from a height the body is thrown above with an angle theta, okay, and the body goes and comes back. So this part is called range. This is called range of the projectile. Here also it's called range. Range is the same. All of the places we will call this range. And then we can have different varieties of this. There are three derivations. Please remember there are three derivations. And all the three need to be little differentiated clearly. But there is no derivation for this particular thing. Only these two derivations will come in the examination for writing part of it. So please remember to learn this particular thing. So how does this one come is projectile given horizontal projection from a height. So there is a height, we are elevated one, and there is a body here and it is given a projection like this. A velocity v is there. So and the body comes and drops here, right? So height is here and the distance is going to be, the range is going to be here. And any point of time we are going to see how this one it travels here. Remember one thing, the horizontal projection always, this velocity will remain same. The horizontal velocity will remain same till the point here. But the vertical projection, the projection will keep on increasing. Look at this one, the arrow mark is increasing every time. This is also will be higher, this will be higher. Now here there is no velocity, vertically it will be because of gravity, the velocity keeps on increasing. That's the way it is. So you have, when deriving, you will be deriving four parts. Path of a projectile, time of flight, range of a projectile, velocity at any point. These are all the 4 points you will be deriving. So please remember there are 4 points in this whole thing. Take a look on this. You have these 4 derivations will be there. Y is equal to g into x square upon 2u square. That means y is proportional to x square. Therefore, we conclude this derivation as path of a projectile. It is a parabola. Y is proportional to x square. Please see the book. You will be able to see the derivation. In the notebook I have derived. You would have written in the register. Please take a look on this. Next one is time of flight. T is equal to under root of 2h upon g. This is the time of flight. Range is going to be equal to the horizontal velocity into time. So u into t. T is the same thing. 2h upon g. You will get this one. And then the velocity at any point, u square plus g square t square under root, and tan beta also it's there. So this derivation is important. Please make sure you understand this. And there are numericals based on this also. The next one is the projectile given a projection with angle theta to the horizontal. So this one will be, there is a ball and you project this one and finally it comes and lands up here. So you have given a velocity v with an angle theta. This velocity v can be resolved into two components, v cos theta and then here is going to be v sin theta. So v cos theta will remain same. Remember, v cos theta will remain same throughout the projectile. Everywhere this horizontal will be remaining same. So this is a very important initial part that we have already discussed. But v sin theta, it will be very high and going on and on, it will be less, and here it will be very minimum. Again it will be going down, it will be an increasing one. So v sin theta will be changing according to the gravity. but we sin the cos theta will be remaining same. The horizontal velocity remains same. That is, these are the basic things. The next one is path of a projectile. What is the value here? Y is going to be equal to what is the maximum height, and what is the time of flight, what is the horizontal range, what is the velocity at any point. These all these 4 things you should understand how to do this one. So we can write this one as y is equal to this y, the path of a projectile. It is x tan theta minus gx square divided by 2u square cos square theta. This is a full derivation. Please derive this one and see the derivation you need to learn properly. This is the very important derivation. In this case, y is proportional to x square. So y is proportional to x square. You will be able to see the value, which is the proportionality of this one, and we say conclude it is a parabola. The path of a projectile is a parabola, right? And the next one is, you get here the time of flight. What is time of flight? It is 2u sin theta upon g. That is the time of flight. Next one is horizontal range. Is going to be equal to u square sin 2 theta. Listen here, sin 2 theta will become, not square theta, 2 theta upon g. Next one is maximum height. U square sin square theta upon 2g will come. This will become 2g, right? Remember, in all the places 2 will come somewhere here. 2g is down, here 2u is here 2 theta is there. Are you able to see 2 theta, 2u, 2g? And somewhere 2 will be there. Everywhere sin theta will be there. Everywhere u will be there. So you need to be a little careful about how it comes. So please write these 3 equations again and again and see. Don't miss this. Very important for numericals. You have time of flight or range or maybe height. You should be able to do that clearly. This one, I think I have derived it one in the next class, that is in that book. I forgot once and then I derived it the next day. So you should have done this one properly. Next one is velocity. Velocity is going to be equal to vx square plus vy square. And then the final velocity will be there as a whole derivation will be there. Please do this one. And tan beta is going to be equal to. But these 4 is very important. And also there's a maximum range is there. If it is a maximum range, then theta should be equal to 45 degrees. And if when theta is equal to 45 degrees, what is the maximum range? This whole thing will become 1. So maximum, R maximum is going to be equal to u square by g only. Because this is going to be equal to 1. So only u square upon g will be there as a maximum range. Okay. This derivations is very important and you need to definitely do all the things. The next one is, if you look at the last part of it, is how this projectile comes. This projectile comes. There is no specific derivation for this. For this one, there is no specific derivation of path of projectile, height of this one. So you don't look at this kind of a thing. But it is only numerical, it is important how this one will be coming. So only numericals have been derived accordingly. Okay. So this book doesn't give much of a clarity on this. So please don't rely on this book for projectiles, the derivation. It is anyhow given there, but not very clear. Please don't rely on this book. I have already given the notes clearly, and in the videos also I have clearly explained. You can learn from that, and if you want, you can come and do the numericals alone from this one. So the projection from the height also is given here. This is part of a syllabus, and then the numerical starts, and then the numerical starts from this one. Okay. So these are all the various things. Now, as far as the numerical goes, there are lots of numericals based on this, right? So if you take a look on this also, based on projectile motion, there's quite a lot of numericals. I think we did quite a bit of them, and there are quite a tough questions also it is there. And also I gave an extra numericals also. I gave a projectile motion worksheet also I gave. Many of you did this one. So please take a look. Projectile motion, cover it up separately. Take a separate time out to do all of them and try to finish it, right? And a good variety of at least working out the minimum thing is this book, the book which you are using, this book, do all the exercise questions. And if you are not been able to trace out, you would have done anyhow definitely all the exercise questions in the book also, in the notebook also. Trace out all the exercise questions, try to finish once. Then you are at least minimum you have done the part of it. Don't come without doing the numericals of it. Okay. Alright children, wish you all the best. Do well. With this motion of plane, the entire thing is now complete. Thank you.